You're probably great at multiprocessing in Python already and don't even know it. Here, I'll show you. I have a file called 1000seconds.py. All it does is call time.sleep for 1000 seconds. So I'm going to open a second tab and run it in the second tab. So now we have two tabs running this program. Great! Two Python processes running independently on my machine. Multiprocessing in Python. All right, so that's how you do that. On to the next subject then. Just kidding. Yes, I do have two separate Python processes running, but I had to start them by hand. How do we write a program to start, stop, and manage these for us? Well, conveniently, there's a module that's very similar to the threading module we used previously. Let's check it out. And that module is called Multiprocessing. From Multiprocessing, import process. Okay, so before I run this, there is a small hitch with using the official Python multiprocessing module. On some operating systems, you can't use this to spin up a new process that runs a function if that function is defined in the same file, as opposed to imported at the top, like this, import my function. That's going to make life difficult for us for example purposes where we want to define and run functions in the same Jupyter notebook. So fortunately, there is a third-party module that solves this called Multiprocess. And you can install it with pip install multiprocess. The multiprocess module has all of the same functions and is used exactly the same as multiprocessing, but it doesn't have this bug with pickiness about where the function is defined. So play around with it, use either of them for these examples, but I'm going to use multiprocess. And also, I'm going to import the time module. This process class is so similar to the thread class we used earlier that I can actually just copy this code. So I'm going to do that and paste it down here. Now instead of threading.thread, we want process. So replace both of those. And instead of T1 and T2, let's call them P1 and P2. This should work exactly the same now. And there we go. Oh, there aren't any results. But of course, remember, processes don't share memory. They get a copy of this dictionary in their own separate memory space, and we have no way of accessing it except if they record it somewhere like a file system or a database. One thing we can do, though, is print the computed value from within the function itself. So rather than returning this or saving it in the results, we just print. And there we go. But you see, it printed them right next to each other. It's not a 14, it's a 1 and a 4. What happens if we add another line in here, like finished computing? So it's printing the 1 and the 4 very quickly. Then it prints, both processes print finished computing, and then we have this extra weird new line. Well, what happens if we add 10 processes to the mix? And again, I'm going to use the same pattern that we used previously with the threads. So processes is equal to a list n for n in range 0, 10, then p dot start, p for p in processes, and p dot join, p for p in processes. And we don't need to bother printing the results. Oh, whoops. Bad syntax there. Okay. And you can see this output starts to look a little bit funky. New lines aren't where you expected them to be. There's overlap between the separate function calls. If we copy our threads code over, we can do a similar thing with that. Let me just copy this. And I'm just going to import the threading module at the top. Okay, and we're going to use the same long square function, so it should print things out. Oh, and let's just do 0 through 10 there. So that actually looks a little bit nicer than with the multiple processes. So what's going on? We usually talk about threads and processes as computing things in parallel, and with processes, that's true. Modern computers have multiple processors, and you're literally asking for multiple processors to process your tasks in parallel. However, with threads, what's happening is that the same processor will execute a statement from thread A, thread B, thread C, then thread A again, and it basically picks them up in a round-robin fashion. It will go to work on a different thread if one of them is hanging around waiting for something for whatever reason, like a time.sleep. So threading emulates parallel computing and can sometimes be very powerful if your programs have periods of downtime where you're waiting for something. In the next challenge, we're going to be integrating threading into the scribe program. Now keep in mind, unless you've written a scribe class that, say, fetches data from a database, this won't lead to an immediate performance improvement. But it is a fun and interesting thing to play around with, so let's go try it out.